Hi, welcome to another lecture on pre-calculus. Topic today is sketching the graph of y is equal to a sine of bx plus d or a cosine of bx plus d. So examples that we have here, for example, minus 1/2 of sine of 3x plus 2. Now, I will insist that here's the correct notation, and what we have here is a bit confusing, that you actually need to have a parenthesis around 3x to avoid confusion. So same thing applies to all of these problems that you see in this section. This is supposed to be well, this one is already correct, and this one is already correct. So somehow when they have a fraction, they think they need a parentheses, otherwise they think they don't. But to be clear, a parenthesis always helps. Okay, so what do we have here? We have three actions. This is one action that you see next to x, that's going to change the picture horizontally. Then we have two other actions. One is this number that's multiplying your function from outside, and this thing that's added to the function at the end. Those are going to affect the graph vertically. So three actions to consider. So here we have, for example, sine of 3x. 3 is going to change the horizontal events in the x direction, and then this number is going to change the vertical look. Also, this one is going to affect the vertical look. As usual, you have two ways of handling these problems. One is by point tracking. You can take the 5 points and track them, see where they go, and plot it accordingly. Or you can talk in the language of transformations. So it's good to do both of them and learn it from two different angles. This problem today is going to be substantially simpler than the previous one, and even though it can be placed in the same light, I'm going to just keep this a bit short. Okay, so we have talked about the following. So if you start with sine of x, that's your parent function, and then if you have, say, sine of some multiple of x, such as 2x, what does that mean? We said as far as transformation is concerned, this is going to compress the picture by factor of 2. So this is a horizontal, this affects the x, horizontal compression by a factor of 2. So everything gonna happen twice as fast. If you had y is equal to sine of, say, 1/2 x, this is gonna be horizontal stretch or expansion. So whatever your word you want to use, expansion or stretch, also by a factor of 2. When we have compression, we can phrase it like this. This is scaling, scale by 1/2. This one we are going to say scale by 2. So either way, we are scaling by the reciprocal of this number. So scale by 1 over b. So if the b is larger than 1, like in this case 2, b is larger than 1, we are going to cause compression. If b is less than 1, but positive, what we are going to have is an expansion or a stretch. Okay, so this is what's going to happen horizontally. Now how about vertical movement? A is going to stretch the function vertically if it's a number larger than 1. If it is between 0 and 1, then it's going to compress the function vertically. If it is negative, it's going to also flip it upside down. So, for example, if I have y is equal to 3 sine of x, this simply means 3 times as tall. So you can say scale vertically by a factor of 3. If I had y is equal to, say, 1/3 sine of x, it says it's going to be 1/3 times as tall, or 3 times shorter. Uh, uh, or you can say scale it by a factor of 1/3. Finally, if you have sine of x, say plus 2, this simply means up by 2. If you have both of these, a multiple in front and addition, just remember you do this one first and you do this one second. When you're going to do your x, it doesn't matter, x and y, either of them can be modified as you wish. So we talked in the language of transformations. Now let's go ahead and do the whole thing by point tracking and see what happens. So let's start with sine of x. Sine of x, we have these basis points to worry about. So this is the graph of sine of x. Sine of 3x, we said, means take this thing and compress it by a factor of 3. So this is 6 blocks, compress it, brings it to 2 blocks. This is happening at 3 blocks, compressing it by 3 happens at 1 block. This is happening at 6 when you compress it by a factor of 3. Excuse me, this is happening 12 blocks. When you compress it, it comes to 4. This is happening at block number 9. When you compress it, it comes to block number 3. So what happens is that when you just look at sine of 3x, it's going to come here and so this green, this red one is sine of 3x. So everything ran 3 times as fast. Instead of going all the way to 2 pi, we are finishing at 2 pi third, which is this location. 2 pi was 12 blocks away. A third of that becomes 4 blocks, and that's where we are going to be. Now, multiply by minus 1/2. That means 1/2 shorter and flipped upside down. So it's going to look very crowded here, but zeros are just going to be 0. When you multiply by any number, they just stay 0. This 1, height of 1, when you multiply by minus 1/2 is going to come down here, and this height of minus 1 is going to go here, and that our graph now is going to look like this tiny wiggle here. So the green one, now the green one is minus 1/2 sine of 3x. Then adding a 2, that is equivalent to a lift. Lift meaning we are going to come all the way up by this amount. So it is going to be coming up to level 2. So this is where a so-called midline is. midline is halfway between maximum and minimum. So here's the midline. It's supposed to be midway between the maximum and minimum. That's where, so we are going to take this green function, see if I can use blue, and lift it up by 2. So a 0 comes to 2. This was at minus a half. It's going to come to minus 1.5. 0 again to here. This was at a half. It's going to come here, and that was 0 is going to go down here. So this is going to be our final graph. It's minus 1/2 of sine of 3x plus 2. Okay, so we did this thing by visual inspection and then language of transformations, which is like gives us a understanding what these numbers are actually doing. Now we did this. Also, let's go ahead and do it by brute force, which is okay. These are elements of our table. So I have the input. I have 3x. Then I take sine of 3x. Once I'm done with that, I can quickly figure out what's minus 1/2 of sine of 3x plus 2. And in the process, I'll figure out what to do with x, figure out where x is. So what do we do? I was going to write this thing in red, so if you don't, sorry for that. So let me write it. So this is our final goal, to calculate minus 1/2 of sine of 3x plus 2. So 3x, we go through our famous angles or easy angles to get a bearing as to where we are. The sine of these angles is simply 0, 1, 0, minus 1, 0. The angle, well, you have to divide all these things by 3, and so we don't need side calculations. Quite easy. Divide this by 3, divide this one by 3, this one by 3, and finally this one, 2 pi third. These are our angles. Taking these, first we multiply by minus 1/2 and then add a 2. So multiply by minus 1/2, this becomes 0, it's still 0, and add a 2. Multiply by minus 1/2, so it becomes minus 1/2, and then add a 2. So that's of course 3/2. This one again is 2. Minus 1/2 times minus becomes plus 1/2, and add a 2, so that becomes 5/2. 0 times minus 1/2 is 0, and a 2. Now we said for keeping track of where we are on the page, it's best to write everything with the same denominator. So 0, pi 6, this is of course 2 pi 6, this is 3 pi 6, and this is 4 pi 6. So we are clear as to where everything located. So this 0 and 2, so that is of course this point. Then pi 6 and 3/2. Pi 6, this is pi 6, and 3/2, this is where we are. I don't know if it's visible or not. 2 pi 6 means 2 block over, and we are back at 2 blocks over. So I am here, 2 pi 6, 2 pi 6 at 2, I'm at this location. Next, I have 3 pi 6, 3 blocks over, 3 blocks over, and I'm at 5/2. This is at this location, and the final location is, well, I ran out of color, so 4 pi 6 and 2, 4 pi 6 and 2. Let's color coordinate this one as well for you. And 4 pi 6 and 2, we have let's color it like this, and that is our final point here. So if you want to do point tracking, or if you want to talk about movements, either way you get the answer. What you want to do is each of these problems, try to do it yourself, come back and compare with what is being done here in terms of either logic or steps, and see how you do. So this one is 3 cosine of 3x. So let's go ahead and do our cosine first. This is our cosine. So this is cosine of x. So let's follow the language of transformation. 3x, what's that going to do? 3x, we said, is going to compress everything by factor of 3. So if this is happening 3 blocks away, now it's going to happen 1 block away. This is 6 blocks away, it's going to happen at 2 blocks away. This is 9, 9 becomes 3. That would be exactly the same as this point. And then this is 12, 1/3 of that will be, of course, 4. So what happens is that you have the picture looking like this. This is step 1 of our. So that is, so far, is cosine of 3x. So we did step 1. Cosine of 3x, compression by factor of 3, horizontal compression by factor of 3. Next, this is 3 times as tall. 3 times as tall, so instead of 1, you're at 3, 0 still 0, this is minus 3, 0, and then 3 again. So by now we have something like this. We have come here, then come down, come back up. So by now I have 3 cosine of 3x. Finally, we are adding a 1. Adding a 1 means lifting everything by 1 point. So this 3 here becomes 4. This 3 also becomes 4. It's minus 3. Excuse me, I made a mistake. That is, I went up by half a block instead of whole block. So what color was it? So 4. I come to 4. This was minus 3, has to come to 2. Now it's getting a little bit crowded here, but this intersection that was at 0 gets lifted up to 1, and that is what this is referring to midline. Like this cosine is oscillating around 0 to begin with. When you lift it, the entire picture is going to start oscillating around that midline. So let me write this thing. This is the midline. Everything was lifted up to this level. So if we were at 3, we went up by 1, became 4. We were at minus 3, we became minus 2. We were at 0, we are going to come to 1. In this 0 also comes to 1. So my picture is going to look like this. Okay. Now, this got a little bit crowded here, but you can see the points that we had. Let's go ahead and redo this problem also with making a table. So I make my table. So what do we have here? 3x is the input. Cosine of 3x is the first step. Then we do 3 cosine of 3x plus 1 as our final answer. And then we need the x as well. 3x goes through 0, pi over 2, pi, 3 pi over 2, and 2 pi. Cosine of 3x goes 0, 1, 0. Oh, excuse me. I guess I'm tired. So this is 1, 0, minus 1, 0, back to 1 again. I was just writing sine instead of cosine. Take these things and triple them, triple, and add 1. Triple of 1 is 3, and a 1 is a 4. 0 becomes 1, minus triple becomes minus 3, and a 1 becomes minus 2. This becomes 1 again, and this becomes 4. X is a third of these angles, so 0, pi 6, pi third, pi half, and 2 pi third, which we said for following the points is 0. This is 1 pi 6 multiplied by 2, 2 pi 6 multiplied by 3, 3 pi 6 multiplied by what, 2, 4 pi 6. We took the common denominator, so we see where everything is. So now we come and say when this is x again, of course, when you are at x equal to 0, your y is supposed to be 4, 0 and 4. So we go in, plant a point here. We make it big here. That's your first point. Next point, you go and say pi 6 and 1. So pi 6 and 1. So pi 6 and 1, you put a point there. Let's label it pi 6 and 1 is the point here that you have to use your pencil or your point plotter to get that. Then you do, so that was this point, pi 6 and 1. Next you go ahead and get 2 pi 6 with minus 2. 2 pi 6 with minus 2 is this. This is 2 pi 6, 2 pi 6, and minus 2. And so on. So 3 pi 6 and so we have 3 pi 6 and 1. That's again the point here. So that is 3 pi 6 and 1. And finally you have 2 pi third or 4 pi 6 and 4. That is the final point that you plant here. So that's 4 pi 6 and 4. You do either this one or this one to get the point, and then you are all set. So in short, we compressed horizontally by a factor of 3, then stretched vertically by a factor of 3, and then lifted up by 1. Okay, so that is what is happening in that one. And let's see, minus 2 cosine of 2/3 of x. So minus 2, let's see, 2 cosine of 2/3 of x minus 2. So that's our target, and we want, of course, first we calculate cosine of 2/3 of x, and that is, of course, versus 2/3 of x itself. And then we want x, and perhaps we want a cleaned up version of x. So we go again 0, pi over 2, pi, 3 pi over 2, 2 pi, cosine 1, 0, minus 1, 0, 1. Now multiply this by minus 2, and subtract another minus 2 from that, so you get what? Minus 4. Multiply by minus 2, that's 0. Go down, minus 2. Minus 2, minus 1 times minus 2 is going to be plus 2. With that, gives us 0. 0 times minus 2 is 0, and then we have minus 2. And then finally 1 times minus 2, another minus 2, gives us a minus 4. How about x? X is a 3/2 of these things. That is, take these angles, multiply by 3/2. Multiply this thing by 3/2, I get multiply this by 3/2. Multiply this thing by 3/2. So what I am doing? I'm saying 2/3 of x is equal to 3 pi over 2. Is that right? So 2/3 of x is supposed to be 3 pi over 2. So I multiply by 3. So if you wish, 2x is equal to 9 pi over 2. Divide by 2. So x is 9 pi over 4. So 3 gets multiplied and 2 is divided, and they get 9 pi over 4. And then we have finally multiply by 3/2, I get 3 pi. Is that right? Multiply by 3/2, I get 3 pi. Clean this up so that we see where we are. 0, 3, denominators better be 4. So this makes it 6 pi over 4. This is good as it is. Excuse me. In this one has to be multiplied and divided by 4, makes it 12 pi over 4. So the gaps that we are going every time, our blocks are pi over 4, and every time we are going 3 blocks. Is that right? So we come here, we have 0 and minus 4. I have a problem here because my minus 4 is erased. So here is, let me make up a minus 4 here for myself. Let's see. So that's my minus 4 now. 0 and minus 4. So I'm going to be, well, let's do the same thing we have been doing all along. So we have 1 0 minus 1 0 1. This is the this is my cosine of x to start with. Now we are doing 0 in minus 4. 0 minus 4 will be here. Let me do the final graph here. 0 minus 4, and then 3 pi over 4. So let's do this one. This is 3 pi over 4 and minus 2. 3 pi over 4 means 3 blocks in minus 2. So let's see. 3 blocks in minus 2. Then 6 pi over 4 and 0. 6 pi over 4, 6 blocks. 6 pi over 4. So let me mark this thing for my. Then I have so let me make sure I did it right. 3 pi over 4, 3 blocks and minus 2, and I'm here, and my coloration is not right. Let me see. Is that right? So that was supposed to be blue. That's my blue, so it came here. Okay, next I have 6 pi over 4 and 0. 6 pi over 4 and 0. Let's color it green. 6 pi over 4, 6 blocks, and at 0. Then I go and choose 9 blocks and minus 2 again. So 9 blocks I'm going to be, this 8, 9 blocks I'll be down here, and minus 2 I'm going to be at this location. Is that right? So that is this location. My final location is 3 pi and minus 4. 3 pi and minus 4. So that is here. So my picture is going to go like this. So what we got is minus twice cosine of 3x and minus 2. Okay, that took a while. Let's go ahead and do final. Sine of this times minus 3 plus 1. So this 3/4 is going to cause what? That number is less than 1, so it makes it stretch by a factor of 4/3. Okay, stretch by a factor of 4/3. Then we are going to go make it 3 times as tall and make it upside down. After we are all done with that, we have to lift it up by 1. So 3 actions. You can do by just talking it through, or you can do by point tracking. So we start with our sine as usual. Sine okay. So compress, stretch by reciprocal of this number by 4/3. Horizontally, you're going to do this. That's for x. Horizontally stretch by factor of 4/3. So, for example, if this is happening at 6 blocks, 6 blocks times 4/3 is going to be 8 blocks, meaning this point is going to come here. Final location of this point is going to be here. This is 12 blocks times 4/3 is going to be 16 blocks. So 16 blocks is going to bring it all the way here, and so on. This was happening at 3, is going to happen at 4. This was happening at 9, it's going to happen at 12. So I did this stretching. Now multiply by minus 3. Minus 3, well, I should have chosen some other color maybe. Let's see. Multiply by minus 3, a 1 becomes minus 3. So zeros stay as they are. Minus becomes plus 3. So let me draw what we have. So that is sine of 3/4 of x. Now multiplying by minus 3, it makes it this is minus 3 times sine of 3/4 of x, and then you want to add 1 to this, so you're lifting it up, so every point is going to come up 1 unit. This was -3 is going to come to -2. This is going to go to 1. This was a 3 goes to 4, and this goes to 1 again, and so you are going to have a picture that is going to look like this. Okay, so I'll leave it to you to make a table and reproduce all of this thing with a table. So what we learned, there are 3 actions. B is horizontal scaling, A is vertical, and D is also vertical shift. So 3 actions, and of course, if you want to make it even more complicated, you can have a C inside, and that would be the last of all this type of exercises. Okay, so until next time, good luck and God bless.